take a look at problem 15 here. It tells us the angle of elevation from a point on the street to the top of a building is 29 degrees. So let's draw that out. Remember, angle of elevation is from the horizon, from the horizontal. So there's 29 degrees. And then if we walk 50 feet further, the angle of elevation decreases to 25 degrees. And then we want to know how tall the building is. Let's call this H. And I'll do the distance from the building to the initial spot is X. So in other words, opposite, adjacent. So we're going to say, oh, the tangent of 29 degrees equals H over X. And if I use my bigger triangle, the tangent of 25 degrees equals H over X plus 50. Notice both problems have H in them, so I think I'm going to solve for H. So in other words, on the left, H equals X times the tangent of 29. And on the right, X plus 50 times the tangent of 25 equals H. Well, I'm going to set them equal to each other. So that is X times the tangent of 29 equals, let's distribute that tangent 25. So I'll get X times the tangent of 25 plus 50 times the tangent of 25. Now to solve for X, let's subtract X times the tangent of 25 from both sides. So then we get X times the tangent of 29 minus X times the tangent of 25. You could have changed these to decimals, by the way, but I like to work with this one. Equals 50 times the tangent of 25. Well, I can factor out my X. So X times the tangent of 29 minus the tangent of 25 equals 50 times the tangent of 25. Well, if I divide both sides by my parentheses, I'll get X equals 50 times the tangent of 29. Try that again, 25. Divided by the tangent of 29 minus the tangent of 25. Well, I think I'll use my calculator at this point to solve for X. So I'll go 50 times the tangent of 25, provided my calculator starts there. So 50 times the tangent of 25, and then I'll divide that by the tangent of 29 minus the tangent of 25. Make sure you close your parentheses, and you get about 264.94. Now that's X. That's not the height. To solve for the height, we'll just go X, which is 264.94, times the tangent of 29. And we get 146.9 about. Oh, to the nearest foot. We'll say 147 feet. And there you have that one. I do believe 16 is the same thing, except we're looking at the angle of depression. It says the angle of depression from the top of a lighthouse to a flagpole, and this on top of a lighthouse. Okay, top of a flagpole. So in other words, here's my lighthouse, and then on top, I've got a flagpole. Okay, and I'm going to draw it down. So my angle of depression is actually right here at 2.9 degrees. It says the angle of depression from the bottom of the flagpole is 2.6 degrees. And then if the boat is 400 feet away from the shore and the lighthouse is on the right edge of the shore, how tall is the flagpole? So in other words, we're taking a look here. I do believe you got to read where it says here. The angle of depression to the top of the flagpole is 2.9 degrees. The angle of depression from the bottom of the flagpole, the boat is 400 feet away from the shore. So this is 400. And we want to find the height, which is h. Oh, I didn't draw it right, that's why. Sorry about that. Let's redo that. We actually have to have two different colors because we're going from the same point. So this is 400, okay? And this is 2.6. I didn't draw it very well. So in other words, I don't know what the height of the flagpole is. Let's call that x. So in other words, the tangent of 2.6 degrees equals the height of the lighthouse, which we'll call h, over 400. And then we can say the tangent of 2.9 degrees equals h plus x over 400. Okay, so I have an h in both of them, so I'll solve for h in each one. So h equals 400 times the tangent of 2.6, whereas h plus x equals 400 times the tangent of 2.9 degrees. If I want to get h by itself, I'll say h equals 400 times the tangent of 2.9 minus x. In other words, 400 times the tangent of 2.6 equals 400 times the tangent of 2.9 minus x. In other words, well, not in other words, let's subtract 400 times the tangent of 2.9 from both sides. Can't write. So the tangent of 2.9. So we're going to say negative x equals 400 times the tangent of 2.6 minus 400 times the tangent of 2.9. So in other words, negative x, let's use our calculator now. So we're going to say 400 times the tangent of 2.6 minus 400 times the tangent of 2.9. And I get about negative 2.1. Oops. Negative 2.1. Round your errors to the nearest foot, so x is going to be about 2 feet. There's our answer for that one.